These are your notes for modeling with exponentials and logs, which is chapter or section 7.7. So on this first part, we're going to determine the type of function represented by each table. So your types of functions we're looking at here are linear. That's when I add or subtract the same amount each time. Exponential, where I multiply or divide by the same amount. Quadratic, which is where the second differences are the same. Or cubic, which is where the third differences are the same. Those are the basic functions I'm going to look at. Now if I look at A, now the x values must be evenly spaced, so these all go up the same amount on the x values. And then I look at the y values, and I want to know how are the y's changing. I'm not adding the same amount each time, but I'm multiplying by 2 each time. So that is going to be exponential because I'm multiplying by the same amount each time. So it's an exponential function. Looking at B, again my x's are evenly spaced, so that I want to look at their y values. I would subtract 2 here, then I would add 2, add 6, add 10, add 14, add 18. So I'm not adding the same amount each time. I'm not multiplying by the same amount each time. So this right here is the first difference. If this were the same, it would be linear. I want to look at the second difference. So I'd go up 4, up 4, up 4, up 4, and up 4. Because these are all the same, this is going to be a quadratic. If it had been the third differences, it would have been a cubic. This time I want you to pause and try 1 and 2 on your own. Alright, number 1, you are going up by the same amount each time on the x's, and the y's would subtract 3, subtract 3, subtract 3, so this is linear. Over here, x's go up by the same amount each time. The y's are dividing by 3 or multiplying by 1/3. And so because they're multiplying or dividing by the same amount each time, that is an exponential. Writing an exponential function in y is equal to a times b to the x, whose graph passes through 1, 6, and 354. So you're going to have some steps for writing these. First thing you're going to do, you're going to substitute for x and y. So what that will look like, this is my x, this is my y, this is my other x, my other y. I'm going to have two different functions I'm working with. So I'm going to have 6 equals, y equals, ab, which I don't know yet, so I'm leaving a and b, and then x value right here is 1. And then this point will be the function 54 equals ab to the third. Then I want to solve one of these for a. I'm going to choose this one. So I'd solve for a by dividing by b. So a is equal to 6 divided by b. Then I'm going to substitute for a in my other equation. So I have 54 times, and instead of a, I'm writing what it's equal to, 6 divided by b times b cubed. Or sorry, 54 is equal to 6 divided by b times b cubed. Got to make sure I have my equals. So 54 is equal to 6. B cubed minus b is b squared. And now I'm solving for b. So I'm going to divide by b, or sorry, by 6. That gives me 9 is equal to b squared. Take the square root of both sides, and b is 3. I'm only looking at the positive right here, not looking at the negative, just the positive square root. Once I've found b, I've got to plug that back in and find a. So I'm going to plug it into this one. It's a little bit simpler. So I have 6 is equal to 3a, so a is 2. Now I've got a and I've got b. I've got to put it into this form. So y is equal to 2 times 3 to the x. A store sells trampolines. The table shows the number of y of trampolines sold during the X year that the store has been open. Write a function that models the data. Do you think the model can be used to predict the number of trampolines sold in the 15th year? Okay, so we're going to be doing this same exact thing. So pick any two values. I'm going to pick year 1 and year 4. So this would be 12 equals AB to the first, and 36 is equal to AB to the fourth. This one's the easier one to solve for A. I'm just going to divide by B. So A is equal to 12 divided by B. Plug that in. 36 is equal to 12 divided by B times B to the fourth. So 36 is equal to 12B cubed. Divide by 12. 3 is equal to B cubed. Take the cubed root of 3, which is not a very pretty number. I'm going to have to use my calculator to find that. Math, cubed root of 3. And I'm going to go to two decimal places, 1.44. So B is 1.44. Now I still have to find A. I can plug that straight in right here. So I'd get A is equal to 12 divided by 1.44, which is 8.32. So my function here will look like y is equal to my A value, 8.32, times my B, which is 1.44, to the x. The next part asks me to write a recursive rule for the function you wrote about trampoline. So you kind of need to know what a recursive rule is. The notes for it are on the back of your notes right here. And so what you're looking at is the initial value. So at 0, what is that A value? And then you want to know for any other point, it's your growth factor, which is your B, times f of n minus 1. So whenever we write this, we're going to have our recursive rule. F of 0 is equal to my A value, which is 8.32. I also have to tell them that f of n is equal to my growth value, which is 1.44, times the previous amount, so f of n minus 1. And that f of n minus 1 just means the previous term. Alright, flipping over. I want you to pause the video and I want you to attempt 3 through 7 on your own. Alright, so 3 through 7. 12 is equal to 2, or sorry, AB to the 2, and 24 is equal to AB cubed. So A right here would be equal to 12 divided by B squared. Plugging it in, I'd get 24 is equal to 12 divided by B squared times B cubed. So 24 is equal to 12B. B is 2. Plug that back in to find A. 12 divided by 2 squared. 2 squared is 4. 12 divided by 4 is 3. So A is 3. So my function for 3, I'm going to write it off in the margin because I ran out of room. 3 times 2 to the x. Number 4. Same thing. 2 is equal to AB to the first. 32 is equal to AB cubed. A is equal to 2 divided by B. 32 is equal to 2 divided by B times B cubed. 32 is equal to 2B squared. 16 is equal to B squared. B is equal to 4. Plug that in. 2 divided by 4 is a half. My function is y is equal to 1/2 times 4 to the x. Number 5. 16 is equal to AB squared. 2 is equal to AB to the 5th. So A is equal to B squared divided by 16. Plug that in. 2 is equal to, I apologize, 16 divided by B squared. 16 divided by B squared times B to the 5th. So 2 is equal to B 16 b to the third divided by 16. That is 1/8. You're going to want to leave this as a fraction. Is equal to 1/8 b cubed. Take the cubed root of 1/8. Cubed root of 1 is 1. Cubed root of 8 is 2. So b is a half. So a is equal to 16 divided by a half squared. A half squared is a fourth. 16 divided by a fourth is the same as 16 times 4, so that is 64. So y equals 64 times 1/2 to the x. Write a recursive rule for the exponential functions. So f of 0 is equal to 4. F of n is equal to 7 times f of n minus 1. Number 7, f of 0 is equal to 9. F of n is equal to 1/3 n minus 1. F of n minus 1. And that just means a previous term. So you'd multiply the previous term by 1/3. Use a graphing calculator. So you'd probably want to use Desmos to find an exponential model for the data of the trampoline problem. Then use each model to predict the number of trampolines sold in the 8th year. Which prediction would you use? Oh, do we think this model could be used to predict the number of trampolines sold in the 15th year? I don't think so, because it's so far past that. So I'm going to say no on modeling. 15 is too far in the future. If it had asked you about 8, yes. 9, yeah. 15, too far in advance. So that is a no right there on if you could use it. So we want to use a graphing calculator to find an exponential model for the trampoline problem. You won't be able to do this on Desmos. This is something you're going to have to do in your calculator. So you go to Stat, Edit, and you're going to type in all of your values. So I have something already in there. To get rid of that, I'm going to arrow up and press the clear button. And then I want to put in my years in Y1 and my trampolines in Y2. From there, I'm going to press second quit. And I'm going to go back to Stat, over to Calc, and I want to look at a exponential regression. Calculate, and we have y is equal to 8.4. I'm going to go 2 decimal places, so 46 times 1.42 to the x. And we want to use that model to predict the number of trampolines sold in the 8th year. So I can 8.46 times 1.42 to the 8th. That is 140 trampolines. Which is, that function model is fairly close to what we found before. 8.32, 1.44 to 8.46 and 1.42. That is fairly close. The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, which is 1.03 kilograms per square centimeter. The table shows the pressures in atmospheres at selected altitudes. Use a calculator to find a logarithmic model. Okay, so now we need to find a logarithmic model to represent the data. Estimate the altitude when the pressure is 0.75. So again, we're going to go to Stat, Edit, clear out these values, and we're going to put air pressure in L1. You always use L1 for your independent variable. And our altitude is and L2. Then I want to press second quit, go back to stat, over to calc, and I'm going to go down to, and this is a natural log, so I need to do an LN regression. I'm going to be estimating it later, so I'm going to go ahead and store this into Y1 by going to vars, Y vars, choosing Y1, and calculate. So that gives me my function, which is y is equal to the a value, 0.863, plus my b value, negative 6.44, or sorry, 45, natural log of x, or p in this case. Your Chromebooks are pretty picky about variables, so you want to make sure that you have the correct variables. Alright, then we're going to estimate the altitude, and the pressure is 0.75. So since I stored this in Y1, I'm going to clear out Y2, I'm going to go just zoom 6, won't be able to see all of this, and I want to find out 0.75, so I just type in 0.75, press trace, 0.75, and that is 2.717. Would be the altitude. And that is in kilometers. Go ahead and write a brief summary of your notes and then work on your online assignment.